In college algebra, we wrapped up this handout and started a new one. I did tell people in regards to this table here and picking points, a good rule of thumb is, now, by the way, this is just advice here. You can pick any 7 points you want to plug in right here. I picked -3 up to +3, and I would recommend using those numbers as long as there's not a fraction in the function. So if a fraction is not attached, struggling to write here, to the x, then just plug in -3, -2, -1, 0, 1, 2, 3. That'll give you nice numbers. It's just if there's a fraction attached to it, it could get a little bit ugly in terms of the result. So we'll look at some examples of those and what to plug in that case. So let's work the last problem in the handout. It's a word problem about the older a person is, the more they wake up in the middle of the night. So you can maybe hit pause and skim through this paragraph up here. That tells you what it's all about. I can tell you that this axis is really important, and so is this axis. So the x is how old people are, and the y is how many times they wake up in the night. And part A is saying, when do women, at what age, do they have the least number of awakenings? So if I'm looking at the black line that has an arrow pointed at women, looks like the graph is lowest right here. And I'm going to guess that that's at about 8 years old. At about 8 years old, women have the least amount of awakenings. And that number, it asks also, what is that number? It's at about 1. About 1 awakening. For part B, it says, when do men have the greatest number of awakenings? So hopefully you're looking right here, and that looks like it hits the x-axis at about 65. About 65 years old is when men have the most awakenings. Which is about 8. All right, part C, it asks you to take it a little bit further. So they're asking you to look at 25-year-old men and women. Let's erase all the markings I've made. Sorry if yours is marked on. Maybe you could use a different color. So this is about 25. And we're looking at that dot and that dot. They're saying, what is the difference in awakenings? So what I would ask you to do is show me your estimate for men and your estimate for women and subtract. If you don't show me your estimates, you are not going to get any credit. because I need to, it's possible that your answer is going to be different than mine, and I need to see what your estimate was. So I would estimate that top red dot to be 3.2, because it looks like it's barely above that line that's at 3. And for the women, I'd say 1.4 or 1.5. It's hard to tell if it's a touch below halfway, but let's say 1.5. So just subtract those two for the difference. And we get 1.7 awakenings. So you guys try part D. Same idea. Estimate when they're 18 years old. Let's go ahead and decide. 18 is these two dots here. So I would estimate the men to be at, looks like it's barely below the 3. Let's say 2.9. And the women is at about, I think it's also below, looks like 1.8 to me. And we subtract these, and we get 1.1 awakenings. You just need to go slow on these word problems and ask yourself questions about what different parts of the graph represent. And it sometimes can be difficult. So take your time and write down info that you know, and then typically you can figure out the question. We also moved on to just solving basic equations. So we looked at linear equations to start out. That's where x isn't raised to a power other than 1. And you do see an equal sign. So we solved these like you've been doing since middle school. Let's zoom in a little bit. All right, number 1, we'll add 600 to both sides. And then divide by 10. And x is 100. On problems like number 2, you need to start inside the parentheses and ignore everything else. So I look inside the parentheses and I have unlike terms. There's no math to be done. So now we slowly move outside the parentheses and we're going to distribute. And you need to rewrite the numbers you don't work with. So we get 2x minus 6 minus 17 equals 13 minus 3x minus 6. I do need to get the x's on one side, but let's simplify first. So I see these two numbers that can be combined, and they're on the same side as the equal sign of the equal sign, so I don't change signs. I get negative 23. 13 and negative 6 are on the same side of the equal sign. They're both on the right side, so I'm just going to do 13 minus 6 and get 7. Now I need the x's on one side, so let's move them to the left. Add 3x. Add 23. And we about have it. Let's try that again. Divide by 5, and we get 6. Let's do number 3, and we'll call it a day. When you see fractions, people tend to panic. So way off to the side, let's make a note to get rid of fractions, multiply the entire equation by the common denominator. So on number 3, I would say the common denominator is 10, because 2 times 5 is 10, 5 times 2 is 10. That's the lowest number, like multiple, they have in common between 2 and 5. 10 is the common denominator. So I'm going to multiply that entire equation by 10. I do that by writing parentheses around it and putting a 10. Next step is crucial. Every single term gets that 10. So I'm going to go 10 times 3x over 2, 10 times x over 5, 10 times 39 over 5. And then you can cross cancel and it becomes a very easy problem. But please don't skip that step. 2 goes into 10 5 times. 5 goes into 10 twice. And then you are so close to being done. We get 15x, 2x, and negative 78. We get 13x, divide both sides by 13, and we get negative 6. All right, hope that made sense. I will see y'all tomorrow.